All right, so let's review simplifying using the exponent rules that we've learned. Okay, so these exponent rules right here, if you've forgotten some of them, make sure you go back and look at your notes and review them. Okay, so I'm going to be using these exponent rules here to simplify some problems for you guys. All right, so first of all, let's take a look at this problem right here. The first thing I would probably recognize is this exponent outside here is negative, right? So some people like to make this exponent positive first and then start working out the problem. It's really up to you. So keep in mind that when you're simplifying these problems, there's multiple ways to do them, right? So your friend might be doing it a little bit differently than you. As long as everyone is using the exponent rules correctly, we should all arrive at the same solution, okay? So for me, typically, even though this exponent is negative, I'll distribute the exponent first, and then I'll worry about making the exponents positive later. Okay, that's just typically the way I approach problems. So I will distribute this exponent to all the terms inside this parentheses, right? So we've got negative 2, right, to the negative 2 power now. So x, so we multiply these exponents, 6 times negative 2 will be negative 12. And then we've got y, so negative 2 times negative 2 is a positive 4. Okay? So now I'm going to worry about the negative exponents. So if I want to make these negative exponents right here, if I need to make them positive, right? So imagine this is over a fraction, right? So imagine this is a fraction, so it's over 1. Anytime if you have negative exponents, all you really do is, if you want to make them positive, you just move the base, right? So if it's on top, right? So these two negative exponents, right? If we want to make them positive, we need to take their bases and move them to the bottom. So I would just move this guy to the bottom, move this guy to the bottom. So then that's going to leave me with, so I still have the y to the 4th at the top, right? So we leave this at the top because this exponent was already positive, right? So that's fine. So these can move to the bottom, so there's negative 2. So you notice this negative 2 here, it doesn't change. It still stays negative 2. The only thing that changes is that this negative exponent now becomes positive, right? Now, same thing, this x gets moved to the bottom, and then this negative exponent becomes positive. Now, on the bottom here, think of it as like a 1, right? So we just have these values on the bottom here now. So now we start simplifying more, right? So all the exponents are positive. I'm going to start simplifying more now. So on the top, there's really nothing to do. I have y to the 4th on top. On the bottom, negative 2 squared, that means negative 2 times negative 2, so that'll give me a positive 4. And then x to the 12th, there's nothing to do there. And then you want to double check, is there anything for me to simplify? It doesn't look like there's anything else for me to simplify, so this would be my final answer, fully simplified. Okay? Okay, let's take a look at this second example here. So similar to the first one, this exponent on the outside here is still negative. So we'll worry about that later though. We'll make it positive later. So the first thing, I'll distribute this exponent to all the terms inside the parentheses. So that'll leave me with negative 27 to the negative 4 over 3 power. And then x, when I multiply 6 times negative 4 over 3, right? So I'm multiplying 6 times negative 4 over 3. And then I also have y to the negative 2 times negative 4 over 3. Okay? So when I do that, that's going to leave me with, so I'll worry about this negative exponent in a moment. So we've got negative 27 to the negative 4 over 3. Over here we multiply, so 3 and the 6, they're going to simplify, right? So we're going to get x to the negative 8. Over here, so it looks like I'm just going to multiply, right? Negative 2 times negative 4, that would leave me with positive 8 over 3. Okay? So now I've got these two negative exponents, right? So I notice these two exponents here, these guys are negative. So I want to make negative exponents positive now. So in order to make them positive, similar to the last example, so think of this like over a fraction, right? So I need to take their bases. So if these are negative, right, these exponents are negative, right, if I want to make them positive, I need to take their bases and move them to the bottom. So I'm going to move these guys here to the bottom. All right, this x also needs to go to the bottom, right? So that's going to give me, so on top is still this y to the 8 over 3. On the bottom, right, I'm going to end up with negative 27. And then this negative 4 over 3 becomes positive 4 over 3, right? And then the x to the 8th, negative 8, becomes positive 8. Okay, so now I'm going to continue working on this problem. So in order to simplify this negative 27 to the 4 over 3, I want to think, all right, negative 27, think of some changes to some sort of power, right? So I know negative 27 is negative 3, right, to the third power, right? So negative 3 to the third power gives me negative 27. And then I still have this 4 over 3 on the outside. So if I follow exponent rules now, I'm going to multiply these exponents. So this is going to be negative 3 to the 3 times 4 over 3. So what happens is the 3's are going to cancel. So basically this just becomes a negative 3 to the 4th power. So negative 3 to the 4th power means negative 3 times negative 3 times negative 3 times negative 3. So that's going to give me 81, right? So on the bottom here now, when I work all this out, right, this gives me 81. So this is x to the 8th, and this is y to the 8 over 3. So it doesn't look like anything else can be simplified, so this would be my answer. Okay? Okay, so let's take a look at this next example now. So this one here, right, a little bit more complex. So first of all, this is in exponent form. But on the bottom, it looks like we have these in radical form. So the first thing we want to do is, let's get everything in the same form, right? So I will change everything to exponent form. So on the bottom here, I'm going to change these radicals into exponent form. Now to do that, remember the whatever type of radical that is, that's just going to become the denominator of your exponent, okay? So this right here is just going to become x to the 3 over 5, right? So just remember that what type of radical it is. So in this case, it's a fifth root. This tells you that this should be the denominator when you change this to exponent form. So this right here, remember, if it's a square root, there's an imaginary 2 here, and if there's no exponent here, there's an imaginary 1. So this is going to give me x to the 1/2, okay? So if you don't remember how to change radicals into exponent form, make sure you review that, okay? Now on top here, this is still x to the 1/2. All right. Now that everything is in exponent form, we should recognize that, well, we have the same base. Like all these exponents have the same base. The base is x, okay? So if you recall from the rule over here, if we have the same base and we're dividing, right? So right here, this rule right here, the quotient rule, if you have the same base and you're dividing, what you do is you take the top exponent minus the bottom. So what I'm going to do is, well, we all have the same base, which is x, right? They all have the same base, which is x. So I would take the top exponent, which is 1/2, and I'm supposed to subtract, right, the bottom exponents. So I'm going to subtract this bottom exponent, 3 over 5. Now, typically when I'm subtracting, I always like to put whatever I'm subtracting in parentheses. Just in case there's more than one term, I remember to distribute the negative. So I subtract here, also the 1/2. Okay, and then we just work this out. So this just becomes, well, I need to subtract these fractions, so I need to get a common denominator. So it looks like the common denominator will be 10. So this is going to be the same thing as 5 over 10 minus, this would be 6 over 10 minus, this would be 5 over 10. All right, so all I did was I just got common denominator so that I can simplify these fractions. Okay, so common denominator was going to be 10. So 5 over 10, 6 over 10, and then 5 over 10 as well. So then if we simplify this all the way down, we're going to end up with x, right? Oops. Where's the page at? Here we go. We're going to end up with x. So the 5 over 10 minus 5 over 10, these cancel each other. So we're left over with just negative 6 over 10. Okay. Now typically we don't want our exponents to be negative in our final answer. So sometimes they'll ask you that your answer should only have positive exponents. So if you want to make this exponent positive, remember, think of this as like over a fraction. So I need to take, right, this base here and move it to the bottom. So my answer is going to be 1 over x to the positive 6 over 10. And then now the exponent is positive. Okay? Okay, so let's take a look at this next example here. So the first thing I'll do is I'll distribute this exponent here on the outside into all the factors on the inside. So that'll give me 32 to the 3/5 power x. Remember, we multiply these exponents, so negative 10 times 3 over 5. And then we have y, we have negative 2 times 3 over 5, right? So if you multiply these, we're going to end up with negative 2 here. So we'll get x to the negative 6 power and y to the negative 6 over 5. And then we also still have this 32 to the 3/5 power, right? So now if we continue to simplify this, right? So let's think. You want to think like something to some power is going to give me 32, right? So use this denominator right here to help you, because usually this is like a good hint. So usually something to the 5th power will give you 32. So actually 2 to the 5th power will give you 32. And then you still have this 3 over 5 on the outside. So when you multiply these exponents, right? So we have 2 to the 5 times 3 over 5. These 5s are going to cancel each other out. So basically this problem becomes 2 to the 3rd power. We know 2 to the 3rd power gives us 8, right? 2 times 2 times 2. Now over here we have x to the negative 6 and y to the negative 6 over 5. Now typically the questions, sometimes they'll tell you make sure your answer at the end doesn't have any negative exponents. So we need to take these negative exponents and we need to make them positive now, right? So imagine this is over 1, right? So that means we need to take these bases and move them to the bottom, right? Since they're on top right now. So that means that on top we're going to have 8, and on the bottom we will have x to the 6 and y to the 6 over 5 power, right? This would be our final answer.